So now we're going to learn how to add and subtract vectors. The basic thing for adding and subtract vectors is that if you go from A to B, and you've got an arrowhead going from A to B, and then you add another vector where you attach the tail of the next vector and go from B to C, well, that's, as far as displacement goes, technically the same as just going from A to C. Sure, you've traveled further, but at the end, it's the same as going from A to C. And that's how we're going to add vectors together. There's the direct route, and then you could go from A to B and then B to C. We say that those are the same thing. The A to C is just the same as A to B plus B to C. So anytime we have one vector going in one direction, if A to B is the vector u, then going backwards would just be the negative of that. So it would have the same magnitude, but an opposite direction. Now adding vectors, we're going to draw this out to see what this looks like. Vector A is 2I, so that would go 2 in the x direction, minus 1j. There's our vector A. Vector B, doing a different color here, is negative I, so that's 1 backwards, plus 3j. Those are our two vectors. So I'm going to just clone them here. So if I wanted to take vector A and then add vector B, here's my vector A, and I add vector B to it, I would end up with this. Because I've taken vector A and I've added vector B. So I end up with that red vector, which is I plus 2j. Now I'm going to rewrite vector A this way, 2 and negative 1. And I'm going to rewrite vector B as negative 1 and 3. And then I'm going to rewrite my answer vector as 1 and 2. Because it will be annoying if we'd have to draw our vectors every time and then count spaces in order to figure them out. So can we see what's happening? Our x coordinates, or like matrices, the x values are getting added and the y values are getting added. If you wanted to see a vector representation of what does B minus A look like, you take B, so I'll start it down here. There's B. Now, minus A would be this one in the opposite direction, so I'm going to put it on there, but I'm just going to put the arrowhead on the other side, make it be all perfect. And then you can see, well, what would I end up? I started here, I ended up there. Now, with the mathematics here, we start with B, which is negative 1 and 3. And if we subtracted A, which was 2 and negative 1, we're going to end up with negative 3, which is what our red arrow shows, and up 4. Finally, if we took 2 of B, there's 1 of B, there's 2 of B, and we added 2 A's, there's 1 of A, there's 2 of A. This is what we would end up with. And of course, six minus 2 is 4. And we can see that our final red vector here goes 2 to the right and 4 up as a result. Could we have just taken our answer in A and times it by 2? With vectors, is A plus B the same as B plus A? Okay. If I take A, if I start with A and add, whoa, that was bad. Where is this? Let's get it back to start. If I add B to that, is that the same as starting with B and adding A? Are these vectors the same length and same direction? Yes. And if you think about what we're doing by adding the same coordinates, it makes sense. So all you have to do is add the same components when you're adding and subtracting vectors. And often when you write them as column vectors, it becomes very easy to do the math. When you write them with the I, the j, and the k, and you add another I, then j, and k, what you're sort of doing is adding like terms like we did in polynomials way back in grade 9 and have used ever since. But it's that same kind of idea. One negative 1, 7. Four, negative 1, and 5/2. Awesome. So one of the things that we start to recognize is that if we're adding vectors together and those letters are the same, if you go from A to B, then B to C, that's the same as going from A to C. Okay, a typical vector real-life situation would be you're flying to Vancouver. There's the direct flight right to Vancouver. There's also the flight that stops at Calgary and then goes to Vancouver. You pay for the flight anyways. It's not like you're getting a better deal having that, oh, I get 2 flights and I get to stop in at Calgary in between. It's usually not necessarily a better deal. Usually you have to pay more to go directly, because most people don't like having to stop in between, because if you want to get to Vancouver, you don't really need to stop in between at Calgary. But as far as their advertising, when you go to check flight costs, all of those options are there because they still get you to the same place at the end. So it's kind of an example of vector equations. And this b in between doesn't really matter. But now if we want to figure out what A to C is, Well, B is 4, 7, and negative 3. And B to C is negative 1, 2, and negative 5. Adding these together, 3, 9, negative 8. They haven't invented three-dimensional smartboards, but it'd be very cool if I could just like draw a vector in three-dimensional space and add another one, and then we could figure those things out. Maybe next year. What's that? We could, yeah, if we just encourage calculus students to start smoking during class, and then we could have laser beams and have all sorts of vectors happening in here. We learned at a last staff meeting that like fog machines are no longer allowed in the division. So I guess there was a play somewhere where they had a fog machine which sent off an alarm in the building, and so the entire people watching the play had to leave, and so now they're banned. As soon as something bad like that happens, that's what we do. We ban it for everything. So the same thing can happen if you're missing a vector. We know A to B is negative 3, 2, negative 6. We don't know B to C. Add my arrowheads over top here. But we know A to C. What am I going to do with A to C? How am I going to write that out? There's only two things. Just write them bigger to fill in things. Add a 0. J is missing. Not with matrices. So then you could subtract the vector on both sides, or maybe you can just see what the answer is going to be. 4, negative 2, and 11. One more example. No, that was the last example. So I'll hand out this homework thing, and we'll take some time to practice it.